For our last shuffle today, we're looking at the Bessey 2-2. So let's show you how this shuffle works. And this is a second shuffle for which I'm not aware of a name for it. So I had to give it a name, so I just call it the Bessey 2-2. Now you can probably guess how this one works if you just think about what the Bessey 1-1 involved. So we'll begin with our order packet, as always. So a Bessey 2-2 is where you take the top two cards one at a time. So you go 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom. So that is the Bessey 2-2, which results in the following new ordering of the cards. And then if we describe this in Cauchy's two-line notation, we obtain the following. We see that the new ordering is 5, 6, 4, 3, 7, 8, 2, 1. And that two-line notation can be converted to cycled notation as follows. 1 goes to 5, so we have an arrow from 1 to 5. 5 goes to 7, we have an arrow from 5 to 7. 7 goes to 2. 2 goes to 6, so we have an arrow from 2 to 6. And then 6 goes to 8. And finally 8 goes to 1, which wraps around, so that completes a 6 cycle in this case. And the remaining two values are accounted for as follows. 3 goes to 4, so we have an arrow from 3 to 4, and then 4 goes back to 3. So that completes a 2 cycle, also called a transposition. If we color code our digits, remember digits 1, 4, 6, 7 are color coded black, and digits 2, 3, 5, 8 are color-coded red. And if we do the color coding, we can see that we get an alternation of colors, including, quote, going around corners, cycling back around. So in particular, this means that black 1 goes to red 5, which goes to black 7, which goes to red 2, which goes to black 6, which goes to red 8, which gets sent over to black 1. Red 3 goes to black 4, which gets sent back to red 3. So in particular, what this tells us is each value gets sent to a value of the opposite color. And when that happens, we say that inversion has occurred. And we can quickly demonstrate that using our quintessential Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0. So let's go ahead and perform the Bessey 2-2. So we do 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom. Let's see what has happened. Do we get the inversion? We do indeed. Now we get 0, 1, 1, 0, 1, 0, 0, 1. So all of the cards that originally were in positions marked by 1s have now been moved to positions that were originally marked by 0s. So they've switched places. So we call that the inversion. So let's take a quick look at this final shuffle diagram. So it's on the bottom row, but on the right, here it is. So we see that 1 goes to 5, 5 goes up to 7, 7 goes across to 2, 2 goes down here to 6, 6 goes up to 8, and then 8 goes back to 1. So that completes this 6th cycle. And we say that all of the values listed here are members of this same orbit. So they just get moved around among themselves every time this shuffle is performed. And finally, the remaining values that we have not accounted for are 3 and 4. Well, 3 and 4 form a transposition. So down here we'll see there is an arrow from 3 to 4, and there is also an arrow from 4 to 3. So those just go back and forth forever. So the objects in positions 3 and 4 trade places every time this shuffle is performed. And because of the 6th cycle here, we know that the Bessey 2-2 has order 6, meaning you would have to perform this shuffle 6 times to reset the packet of 8 cards back to its original order. And over here we've indicated that inversion has indeed occurred. And we are finally ready to take a look at an application of all of this.